Today we're going to talk about evaluating piecewise functions, graphing piecewise function, and continuity of piecewise functions. So we're going to start by discussing evaluating piecewise functions. And so we're going to start off with an example. So if I give you f of x equals 1 minus x for when x is less than or equal to 1, and x squared for when x is greater than 1, we're going to evaluate f of x at x equals -2, 1, 2, and 3. And so first we're going to evaluate f of -2. And so we need to look at the domains up here and determine which one is true if we use the value of x equals -2. Well, we're going to use the rule 1 minus x because -2 is less than or equal to 1. And so we're going to be using this rule here because it follows this domain next to it. So when we do that, we're going to say 1 minus -2, which is the same as saying 1 plus 2, and that gives us 3. So we know f of -2 equals 3, and that's our answer for that. Next, we're going to evaluate f of 1. So again, we're going to look at the domains, and so we're going to use the rule 1 minus x again because 1 is less than or equal to 1. So when we do that, we get 1 minus 1 equals 0, and so we find that f of 1 equals 0, and that would be our answer for that. Next, we're going to do f of 2, and so for this one, we're going to use the rule x squared, and so we're going to use the rule x squared because 2 is greater than 1. And so when we do that, we get 2 squared, and that equals 4, so f of 2 equals 4 is our answer. And then last, we're going to do f of 3, and again, we're going to use the rule x squared because 3 is larger than 1. And so when we do that, we do 3 squared, and we get 9, so we find that f of 3 equals 9 is our final answer. Next, we're going to talk about graphing piecewise functions. And so if we start off with an example, and we have f of x equals x squared if x is less than or equal to 1, or 2x plus 1 if x is greater than 1. So I'm going to go ahead and draw myself a set of axes. And then I'm going to make two different tables. So I'm going to start with the first rule, x squared. So I'm going to make a function table for that. So we have x and then x squared as our y column. And we're going to start at this value here of 1. It's a less than or equal to sign, so we're going to have a closed circle right there. And then we're going to go to values less than, so that's going to go to 0, -1, -2, and then that's going to continue forever with an arrow on the end. Now we evaluate, so if we do 1 squared, we get 1, 0 squared is 0, -1 squared is 1, and -2 squared is 4. So now we're going to graph this. We have a closed square at 1, 1. And then we do 0, 0, and then we have negative 1, 1, and then negative 2, 4. And then this is a quadratic equation, so we're going to connect with a parabola, just like that. And then I'm going to create another table for my second rule here. And so I'm going to have an x column, and then the y column is going to be 2x plus 1. And we're going to start at the value of 1 here, but it's just a greater than, not equal to sign, so that's going to be an open circle right there. And then we're going to go values greater than, so 2, 3, 4. And then it's going to continue on with an arrow on the end. And so now we're going to evaluate this. So we're going to say 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And 2 times 4 is 8, plus 1 is 9. And now we plot. So we have an open circle at 1, 3. And then 2, 5. And then 3, 7. And then 4, 9. And then we connect with an arrow on the end. And that would be our graph for that function. And then lastly, we're going to solve for continuance, or continuity, however you want to use it. And so if we are given the function f of x equals 2x squared plus x minus 6 when x is greater than 1, and then 2x plus p when x is less than or equal to 1, we need to use this common x value that we have in our domains and try to figure out at that x value what can we make p here equal in order to make our two rules, these two rules right here, have the same y value. And so we want them the same y value, so we're going to take those and we're going to set them equal to each other. So we're going to say 2x squared plus x minus 6 equals 2x plus p. And then from here, we're going to substitute in that common x value of 1. And so we're going to say, okay, 2 times 1 squared plus 1 minus 6 equals 2 times 1 plus p. Now we simplify. And we find that negative 5 is equal to p, and that would be our answer.